We're gonna go out and collect some samples today.
It's a frigid fall morning on the Tillamook Bay.
We're loading up, we've got all our equipment. Just gonna go out to the marina and west and down the West Channel.
Researcher York Johnson and biologist Ron Wren
He's been gracious enough to take us out to our site today.
set out on their last research expedition of the season.
I'm happy with sunshine and a little wind.
And they invited us to come along.
We're headed south down the West Channel.
This is the front line in the study of how climate change is changing our oceans and impacting marine life, specifically oysters. Something in this water is killing them, and these researchers want to stop it.
It's about a 10-minute boat ride from the marina out to the test site. It's late October, so it's pretty chilly out here. Temperatures in the 30s, but at least it's not raining.
This was the day I was most worried about because, you know, it's getting closer to the fall and winter season.
But when so much depends on your research, a little sub-freezing wind and near-freezing temperatures
All right, we're at the site.
don't really
There
matter.
are buoys right in front of us. Okay.
Because what these scientists are studying is a big
All right, here
deal.
we go. It's really important.
To truly understand just how important, we'll have to rewind the story about 12 years.
We came in here one day and we had billions of larvae that died overnight. Nothing in this facility was alive. Mass mortality.
It was a day shellfish farmer Mark Weigart remembers vividly.
We had no idea what was going on.
Weigart was working at the decades-old Whiskey Creek shellfish hatchery in nearby Netarts when one morning in 2007 he arrived at work to find every single young oyster dead.
The shells weren't forming. They were just damaged from the get-go. And we thought it was a bacteria. We had no idea what it was. Within a week, we had people from the governor's office here. We had Oregon State scientists here.
We saw some pretty severe problems with oyster larvae.
Even we came to the hatchery to cover the unexpected and mysterious mass die-offs.
We had about 90% mortality of oyster larvae in the hatchery.
Researchers eventually traced the die-offs not to any bacteria or disease, but to the water in the bay. You see, the water the hatchery uses to grow the oysters in the tanks is pumped in directly from the bay.
This is our source right here.
Scientists got to work testing that water and quickly discovered high levels of CO2.
This is Netarts.
The water in Netarts Bay had actually gotten so acidic, the juvenile oysters couldn't form shells and died.
And then next thing you know, somebody said, well, it's ocean acidification. We really didn't know what that meant.
But they would soon learn. Ocean acidification occurs when carbon dioxide is released into the atmosphere from the burning of fossil fuels. About a third of that CO2 gets absorbed by the ocean. Once dissolved, the gas combines with the water and forms something called carbonic acid. The more the CO2, the more acidic the water. To survive, the hatchery had to find a way to make that water less acidic.
We got to throw the book out on how we raise oyster larvae. We're not dealing with the same ocean. The reality became, we can't fix the ocean, but we got to fix the water coming into the hatchery. After the water comes in,
Now all the water that comes into the hatchery is treated with soda ash.
as you can see, it's pumping the buffering agent right into the main line.
To increase the pH levels so the juvenile oysters can form shells and survive.
It's like a morphine drip, you know? Yeah. It's taking the pain out of the water. There's all these little tricks you learn along the way, and if you know, you can't learn them fast enough.
The water coming in from the bay is constantly monitored. The hatchery even set up a special room
There's a percolator here.
just for researchers,
This is a monitoring system. This is scientific data being collected.
Yeah.
which brings us back to Tillamook Bay and on board that small research boat.
Perfect, just up a little closer. This was a kind of an eye-opener for Oregon and the West Coast. And basically, Oregon decided that it needs to set up a monitoring network to see, to track changes in ocean conditions. So the goal of this effort is try to establish a cost-effective way to monitor ocean acidification over the long term. All right, here we go.
For the last year, Johnson has been tracking just how acidic the water in this bay is.
Yeah, the sample collection is pretty quick.
The final samples of this testing season.
All right.
Measurements are taken.
Salinity is 19.9.
The water temperature recorded.
Temperature is 7.8 degrees C.
Yes, that's a beer bottle Johnson is holding, but it's not for drinking.
So what do you got there? That looks familiar.
It's just a normal beer bottle. Yeah.
It holds in the CO2 when it has beer in there, and it holds in the CO2 of the sample. is what you're saying.
Exactly. This will be a little flatter than your typical beer, though.
It's filled with bay water, then capped.
This is going to OSU, this is going to OHSU, PSU. That's it, that's a wrap.
Now that the samples have been taken and the equipment pulled, the next step is to get those samples to researchers so they can figure out what's really happening with the water in this bay.
They already know the ocean is acidifying. That data is clear. What they're hoping to learn with projects like this one is how fast it's changing and how marine life will adapt. The problems that started with the oysters are already impacting Oregon's mussels. While the adults will survive, the young mussels likely won't be able to. Researchers believe Dungeness crab could be next. Then there are the salmon. Studies have shown acidic water impairs the ability of fish to find their way home. Acidic water will reshape our ocean. The question now, what will it look like in 10, maybe 20 years?
Is there anything we can do?
Well, I think that's one of the questions we would like to answer, but I think, the hope is that yes, there is.
We have monitors here that
It's a
tell us
hope
the
those who
pH of
depend on
water.
the ocean for their livelihood hold on to, despite what many are seeing.
Has the pH gotten any better? No. I think it's actually gotten a little worse. It's just that we're a little bit, now that we know what we're dealing with, we're a little bit better at dealing with the problem. So that's larvae there.
In the 12 years since this crisis began,
Simple way of
Whiskey
saying it's
Creek has become somewhat of a poster child for the problem.
The Whiskey Creek story about ocean acidification just never seems to go away. People want to hear about it a lot. And of course, we live it, so sometimes we'd like to have it go away.
But they know this story will be told for a long time, a story about a vast and beautiful ocean that is sick.
There are actually things that we can do, each and every one of us, to make it better. Someday, we'll all get to that point where we don't have much time left in this world, and you're going to sit there and you're going to wonder, did I do enough?